Alright, question number 10. This is the last question in this question paper. O is the center of the bigger circle. O is the center. See, O is the center. Guys, if center is given, then many ideas you will get it. You can identify all the radius. Here you can see how many circles. Two circles are there. One is this bigger one, then the other one is this smaller one. Okay. All right. Now before I go to the further questions, I can explain something. Can you identify all the radii? See, OT, this OT, then OV, this OV, then OU. See, all are radii. Do you see that one? I'm talking about the bigger circle. These all are radii. All right. Now, radii I'm done. Now, can you see diameter? See, TV is a diameter. This TV is a diameter. Isn't it? This diameter is subtending the angle S. The full S is 90 degree. See, those ideas, it must be there in your mind. That will help you to do questions. All right. We already said that radii. See, if it is a radii, these two angles are equal. Isn't it? Because these two are radii and they are equal. Angles opposite, equal sides. Do you see that one? Okay. Same way, if you see parallel lines, identify corresponding angles, alternate angles, and co-interior. All right. Now, what else you can see that because center is given, can you see that theorem angle at the center 2 times angle at the circle? See, angle at the center, this 2x, angle at the center. Then angle at the circle means, look at the bigger circle because center is part of the bigger circle. So from U and V, what are the angles subtending? And angles subtending at the circle, S1. See, T and U subtending S1, and T and U subtending V3. This also. These are the angles. They are same, isn't it? Okay, which means what are they? This is angle at the center is 2x, mean these are x and this also x. Remember, these two angles are same, which means this also x. Isn't it? Yeah. So those are the things you need to know. That is the answer to the first question. Name the 4 other angles which equal to x with the reason. 8 marks question. You already found how many of them? 3 of them we got it. So we can write it 10.1. S1, angle S1 is equal to x. Reason is angle at the center is equal to 2 times angle at circle. Isn't it? Similarly, V3 also x. V3 is also x. The same reason, right? Yes. Then U1 and U1 plus U2. U1 plus U2 is also x. What is the reason? Angles opposite equal sides. They are the radii, right? Angles opposite equal sides. Equal sides. Do you understand that? Because V3 and U1 plus U2, they are opposite. This is the radii, OV and OU. Is it clear? Now we need one more. Look at the smaller circle. Did you see this UO? Let me rub this one. Look at the smaller circle. This is a chord. Sorry, this chord. This chord is subtending one at V3, then other one is at W1. Did you see that one? Both are same, are coming from the same chord. So W1 is also equal to V3. V3 is already x, so W1 also x. So we can write W1 also is equal to x. The reason is angles in the same segment. In the same segment. See, 8 mark in your pocket. Did you see that? So very easily we can get it. Only those knowledge: angle at the center, 2 times angle at the circle, then radii, isosceles triangle, then chord subtending same angles in the same segment. So with the help of that, we got all of them. Is it clear? All right. Now we can go to 10.2. Determine the size of W2. Where is W2? This one. W2. So you have to relate W2 is equal to some other angles. Yes, W2 is there because of this chord UVs. Look at the chord UV is subtended in the smaller circle. W2 is subtended by the chord. Is there any other angle subtended by this? Yes, see, what is that? O2. See, O2 also subtended by the same chord. So chord is there. Guys, look at that. In the smaller circle, OWVU is a cyclic chord. If it is a cyclic chord, look at the sides of the cyclic chord. All are chords. Isn't it? They all are chords. So chord, when it comes to chord, angles in the same segment. So UV is a chord, and those two angles, W2 and O2, are subtended by UV. Is it clear? So O2, can you get it in terms of x? Because O1 is 2x. Okay, angles on a straight line. So O2 is 180 because 2x plus O2 is equal to 180. So O2 is what? O2 is equal to 180 minus 2x. Reason is angles on a straight line. Angles on a straight line. Isn't it? And W2, the given angle, the one that we have to express in terms of x, W2 is equal to O2, isn't it? W2 is equal to O2. What is the reason? Angles in the same segment. Isn't it? W2 and O2, they both are coming from the same chord, UV. Isn't it? Therefore, what is W2? W2 is equal to 180 minus 2x. Got that? So this is how we can do this question. Okay? Yeah. Now we can move to last question 10.3. Prove that WS is equal to WV. Alright, so we have to show that S2 and V1, they are same. If we can show that, then we can say that WS and WV are equal, because those are the sides opposite to equal angles. So how do you show S2 and V1? They are same. So find out the value of S2 and find out the value of V1, and if you get both are same, then we are done, isn't it? So guys, in the beginning I said that TV, this TV is the diameter. So what is this? S1 and S2 is 90 degree, isn't it? S1 and S2, that is 90 degree. So 10.3, let me write that one. 10.3, S1, angle S1 plus S2 is equal to 90 degree, because the diameter PV. Reason is angle subtended by the diameter TV. Okay, diameter, if it is a diameter is always subtending 90 degree, isn't it? Always subtending right angle at the circumference of the circle. Okay, and we already know that what is S1 by angle at the circle. S1, we got it already, the x, isn't it? In the previous question 10.1, we already did that one. S1 is x, so x plus S2 is equal to 90 degree. Therefore S2 is equal to 90 minus x. Okay, so we got a value in terms of x for S1. Now check V1. If you get the same thing, then we are done, isn't it? How do we get it? V1, okay, V1, how do I bring that V1? At this stage, we don't know S1 and S2 and V1, they are same. In the previous question, we got the value of W2. This W2, look at this W, this angle, and this triangle WSV, this triangle, okay, where S2 and V1 are there. This triangle, what is this W2? W2, isn't it exterior angle? Yes, because I want to get a relation where V1 must be there. So W2 we can write, W2 is equal to S2 plus V1 because exterior angle of a triangle, isn't it? Exterior angle of a triangle. Exterior angles of a triangle. Isn't it? Okay. Now, what is W2? W2 is same as O2, isn't it? Because subtended, we talked about this one, subtended by this chord in the smaller circle W2 and O2. What is that? 180 minus 2x. Isn't it? That is the answer to question number 10.2. And S2 is what? 90 minus x plus V1. Clear? All right. Now we can find the value of V1. What is the V1? Send 90 other side, x other side. So that is 180 minus 2x minus 90 plus x. That is V1 is equal to 180 minus 90 is 90 minus 2x plus x is minus x. Did you see that 90 minus x? This also 90 minus x. Isn't it? So S2, we can see that S2 is angle S2 is same as V1. Therefore, we can say what? Those two sides. What are the sides opposite to those two equal angles? WS. Therefore, WS is equal to WV. WV. And what is the reason? Angles, sides opposite equal angles, isn't it? Side, because you are proving sides are equal. So you have to write the reason: sides opposite equal angles. So this is how we can do this question. Okay.